Yeah, welcome to the first afternoon session. My name is Gunther Hübner, and I have the honor to be the chair for this session. And my task is to be a bit the timekeeper and moderate everything. So my favorite subject for more than 15 years are printed batteries, and we will hear a lot of this energy providing materials. So our first speaker, I'm proud to announce Harsha Kolli from the company Printed Energy, and he will tell us about printed batteries, any shape, anywhere.
Hello, everyone. Welcome to the talk. So I'll be talking about printed batteries in general and what Printed Energy is doing at the end of our talk, and how we are actually enabling the next generation of thin, flexible, powered electronics today. Right? That's the main theme of the talk. So when we started getting into the market, we were doing some studies, and we talked to one of the big players in the pharmacy industry, and he said, we care about being sustainable, we care about being eco-friendly, but at the end of it, it has to be an economical solution. If it's not an economical solution, it won't be adapted across the spectrum. It will only be adapted in small markets, not big markets. So this has been our motto at Printed Energy, to make economical solutions from a battery space. And that's also very key for any printed battery technology, is what we believe, for mass adoption in the market. So when we get into enablers of printed batteries, it's material science. That's the core of printed batteries. And the most important part is the electrochemistry. And it's a hard science. It's hard to develop electrochemistry. And it has to be developed for pulse loading, because most of the applications in sensory space, IoT space, are designed around pulse loading. And we have to design that electrochemistry for pulses. We should have the material that is readily available. We cannot have something that has stressed supply chain or anything that's expensive, which goes to the next point, cost effective. At Printed Energy, from the start, we were focused on only selecting something that can be bought in bulk and with a very cost-effective price when we were developing our chemistry itself. So, and it should provide optimal performance for the application with IoT or medical devices or any flexible electronics or thin film electronic devices. And one of the most important for our customers, or any customers of printed batteries, would be, it has to be non-toxic. And it has to be very safe. That means non-flammable, easy to ship around in labels or any small things that just disappear in the supply chain, for example. And it should be able to conform to any shape, because customers have different kind of products. Some are medical devices, some are labels. It depends on where we are using them. It changes, and we have to conform to any shape for it to enable multiple technologies. And it has to be fully printable. It's very important to reduce the number of steps you need to make a functional device. If you make it fully printable, you are reducing an overhead of any other conversion or any steps that you need to make finishing batteries. And being fully printable is an advantage of printed batteries that enables making it easy in volume. That's the most important part. To cover the whole aspect, it has to be safe. It should have cost constraints. They're generally for low mass devices, and in our case, fully integrated. We make batteries that are fully integrated with the circuit, not as a separate component. And these are all the enablers that Printed Energy brings to the table as well. So